can? Well, let me show you HUDrive in my Batmobile. Join me inside. Before I tell you about HUDrive, you also have to see the problem with the current commercialized GPS devices. Current GPS devices, as you can see, are usually manufactured by the car manufacturer. They could be coming inside the car or external, as this one, external GPS unit, which the driver only has to attach it to the windshield. There are a lot of problems with these device units, and our project team decided on capitalizing on this issue and try to fix it. The biggest issue is with distraction. It becomes very distracting for the driver to have to look away from his field of vision and onto the GPS unit just to enter a destination or follow with the routes. This causes is a huge safety hazard for not only the driver and the passengers, but also the outside environment. So this is typically what a normal a person with a GPS device would have to do, is get in the car and try to play around with this and fix it every time on the routes. You can see this is just getting into the password is a task. What we're doing is projecting the navigational routes onto the windshield right here. So all the driver has to do is continue driving and look straight ahead onto the road. The GPS routes will be visible to the driver without having to move, not a single bit. So with HUDrive, you cannot go wrong.
Now we're going to be talking about our implementation of the HUDrive. In a traditional heads-up display, the first section would be the image source. So for us, we use an Android device, and this Android device, we put a GPS application on it. This GPS application we programmed ourselves, and this is what eventually you'll see on the combiner. So our next step after the image source, which is the Android device with the GPS application, the next step is the culminating optics. Now, usually, the way that's done traditionally would be a mirror and two plano convex lenses. For us, that was difficult not only because of the price of the lenses and finding the right lenses, but also the physical setup. So usually, in traditional heads-up display, you'd have your windshield here, a lens here, and the projector here. So in our case, this would be floating in midair. So of course, there's no way to stabilize it, and the setup doesn't work. The lens would be an obstruction, so this was not possible. So for us, what we did was connect this to the projector. First, the output of the Android device would be micro USB, and we connect to the MHL adapter. And this converts the micro USB to audio and video. And now we use the HDMI. Connect to the projector that we place over here. Now, since our projector has no audio, we put the audio and connect to the car's auxiliary. It's not going to be shown on the block diagram, but it's basically just your typical cable, audio cable, and you connect to the auxiliary of the car. Now, when we connect to the projector, our next part, this around here, would be the image source. Now, including the projector, sorry. Now we need to do the culminating optics. Again, we're not going to be able to use the lenses or the mirror. So our replacement, which is even simpler, is projecting straight onto the dashboard. And from the dashboard, it reflects up, and you see the image out here, which is what our goal is. It avoids the use of any mirror or lens, which was good financially, and it worked better. It's an easier physical setup to implement. Now this is the culminating optics. After the culminating optics, we have the combiner. Now the combiner is where you want to see the image, and it combines the optical image with your field of view, which in our goal, we want to see it right out here. Now a windshield is only transmissive and it has no reflective properties. Because of this, we had to add another component, which is the reflective film, so we put that across the windshield. So overall, you start with the image source, which is the GPS application, connected to the MHL via micro USB, connected to the projector via HDMI. Now this image source projects the image onto the dashboard and up. This projection and reflection outside is our culminating optics. And finally, the last stage traditionally is called the combiner, which in our case would be the windshield and the reflective film. And in the end, you see it out here. So the image is not on the windshield, it's outside the windshield, so it's not distracting and you don't have to refocus your eyes. That is basically our setup for the implementation And the rest of our implementation had to do with designing the app, but physically this is what our setup would look like.
So as we mentioned before, our controller is an Android device, but the software that will be running on it is a custom-made GPS application that will show the driver route guidance right on the windshield. So in order to do this, we needed to get directions from somewhere because the scope of the project wasn't to make our own directions or our own routing algorithm. The way we obtain directions is we connect to the Google Maps server, which is actually very ideal because then you would never need to upgrade any map software with the application. It just runs off the Google server. So you connect to Google server, you construct a URL with the destination that you want to go and your current location, which is information that is obtained off the GPS. With that, you construct a URL, you connect to the server, and then the server responds back with a JavaScript object, also called as a JSON object, and that has a lot of information about the route that you are about to drive, like starting points, every leg and every instruction that you need to take in order to get to your destination. So we basically just take the JSON object and we parse it, and we parse it and start making a visual layout with the information that we obtained. So for example, if we're going straight, like before any turns, we would have a straight arrow, and then we always keep in the corner here the next direction that you have to go and the distance remaining. Also, we have the speed on the side here so the driver does not have to look down on the dashboard and look at his speed. He can keep his eyes on the road. And also we have instructions that give you very simple, like which direction you're going to turn and on what street. At the same time, we also have audible instructions so that there's a voice that will tell the driver when to turn, and it will do so at certain intervals, like for example at 10 kilometers, at 3 kilometers, 1 kilometer, 500 meters, or as soon as they have to turn. Alright, so it's also very important that we flip the image that we will be viewing because, as Peter previously mentioned, the image will be reflected off the dashboard onto the windshield, so it will be upside down. So that's why here, as you see, the image is upside down of what you would actually see. So as we said before, the app will be running on an Android device, and we'll show you how our app works. As you see here on the screen, this is what the app looks like, the icon from the outside. Once you get in, you are prompted to begin. Here you will be asked to set your destination address, and you're also given certain settings that you can choose between avoiding tolls or avoiding highways, so you can check these or not. And then you click go. At this point, this is what will be projected onto your dashboard and will be reflected onto the windshield right side up. So this arrow, for example, would show straight ahead on the road. So this would be the arrow you would be following. Here are actual written directions. So for example, this one says turn right onto Badminton Drive. Very simple directions. On the side here is your anticipated turn and the distance until your anticipated turn. And on the side here would be your speedometer, which will be continually updating, so the driver can keep their eyes on the road and not look at the dashboard. And that's basically how the app works.
So here are the components of the HUDrive. First, the GPS application, which will be running on an Android device. So this Android device is the Samsung Galaxy S3 right here. It has an operating system of 4.0 or higher. You can use any Android device which has an operating system of 4.0 or higher. And so this is connected to the projector using an MHL adapter right here. And this is connected from the S3 to the MHL adapter using a micro USB. And then this is connected to the projector using an HDMI cable right here. And this HDMI cable connects to our projector that we chose in this case to be a microvision pico projector, laser pico projector. And we can use, so this projector has a brightness of 15 lumens. We can use any micro projector which has a brightness of 15 lumens or higher. And that's it about the projector. The last thing in our project was the reflective film, which is the most important and crucial part of our project. This film right here is a semi-reflective and transmissive film. We need this to be onto the windshield, so that because the windshield is all transmissive, we need to stick this onto the windshield so that the driver could see the projection of the GPS application that's on it. And the last piece is our projector holder. Yeah, so this is flexible, and we stick this on, the projector goes onto this, like this, and we have it stuck onto the windshield. And yeah, that's about all the components of the HUDrive.